Hello everyone. Today we will see a program which generates a prime numbers up to a given number. The methodology what we are going to adopt is the Sieve of Eratosthenes, which is proposed by the Greek mathematician Eratosthenes. So let us just see how the method works. So first accept the number from the user till where you want to generate the prime numbers. So let us assume that the number is 30. So you have a list which is up to 30 starting from 2, then 3, 4 up to 30. So we have a list of the numbers that is 2 to 30. Now, how the method works is that first it starts with the first number which is there in the list. So the first number in the list is 2. Now, 2 is assumed to be a prime number. Now, the multiples of 2, that is 4, 6, 8, 10, 12, all being composite. So all the multiples of 2 which is up to 30, all those numbers are not eligible to be prime. They are all composite numbers. So we'll delete those numbers from the list. So as the name goes, sieve is filtering something out. So this method is actually filtering out the prime numbers up to a given number. So once after doing this process, you will have only the prime numbers left. So we started with the 2, then we are generating, or we are computing the multiples of 2 up to n, and then we are removing those numbers, those multiples, if they are existing in the list. So 4, yes, that is existing, we are removing. 6, we are removing. 8, removing. 10, removed. 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. So again we are going to loop back through the process. So we come back. So we started with the 2. So 2 is assumed to be a prime number. Now which is the next number in the list? So the next number in the list is 3. So start with the 3 and the multiples of 3, starting from 3 into 2, that is 6. So 6 is already removed. Now 3 into 3, 9. See, that is a composite number, that is getting removed. 3 into 4, 12, already removed. 3 into 5, 15 is there, so that is removed. 3 into 6, 18 is already removed. 3 into 7, 21, so that is there in the list, that we are removing. 3 into 8, 24, that is already removed because it was a multiple of 2. Then 3 into 9, 27, that is removed. 3 into 10, 30, that is already removed. So we reach the limit up to 30. Then come back. So here the next number is 5. So take 5 and start with the multiple of 5. That is 5 into 2, 10 is already removed. 5 into 3, 15 is already removed. 5 into 4, 20 is already removed. 5 into 5, 25 is removed from the list. Now 5 into 6, 30. So we reach the end of the list. Now actually, now if you could observe, the next number which we could find out is 7. So your n was 30 and the square root of 30 will be 5.48, kind, a number which is between 5 and 6. So actually you can stop this process till you reach the square root of n. So 7 you need not compute. Now if we could observe, the numbers which are left with, the numbers which are left with in the list are all the prime numbers up to the number 32, 3, 5, 7, 11, 13, 17, 19, 23, 29. These are the prime numbers till the number 30. So this is the method what we are going to adopt to compute the prime numbers. So let us go back to the Python code which is written here using the spider IDE, and since we want to compute the square root, we have imported the math package, math module. So first line, as always, this is the comment line which is indicating what is the purpose of the program. So write a Python program using Sieve of Eratosthenes method for computing primes up to a given number, and very clearly we are specifying that use the list class. So we are going to do this with the list. Okay, now we are first accepting the number from the user. So in our case, as done, so n is equal to 30. Now prime is equal to null list. So you first created an empty list. Now you are going to append that particular list or fill the empty list with the numbers from 2 to 30. So we require this, right? Okay, so we are using a for loop for I in range starting from 2 to 30, actually 31. So 31 will be left out, 2 to 30. You create a list by using the append method. So prime dot append of 2, prime dot append of 3, prime dot append of 4, like that it iterate till prime dot append of 30. So once this loop iteration is completed, you will have a list like this, the name of the list being prime, and you have got a list which is having the numbers starting from 2 to 30. So the list got created. Now we are initializing a variable I is equal to 2. So we are assuming that is the first prime number. Actually the first prime number is 2 because 1 is neither prime nor composite. Now we are using a while loop. So you are starting from 2 and you will iterate till the square root of n. So if you could recall that in this list, by the time we reached 5 and we took the multiple of 5, all the composite numbers were eliminated, sieved out from this list. So what was left with was the prime numbers. So that is why this we are starting from 2 and we will iterate till the square root of n. So math dot square root of 30, it will be 5.48 kind, and you are extracting the integer part. So it will be 5. So it will start from 2 till 5, right? Okay, then we got inside the, so first the I value is now 2, we got inside. If I is in prime, so if I is in prime, yes, the first number, so this is your prime list, so I is available in prime, 2 is available in prime. Now your job is to delete the multiples of 2 till 30, right? So for j in the range I star 2 n plus 1 2 to 30, and you are stepping it by the value 2, right? So 2 star 2, 2 star 3, 2 star 4 kind it will go. Okay, so it will be first when you are starting with it, your starting value of j is 4. It will iterate till 30, your stepping value is 2. So if 2 if j in prime, the first value of j is now 4, right? So it is 4. So 4 in prime, yes, print remove, sorry, prime dot remove j. So you're going to remove the value j from the list. So 4. Now when back here step by 2, so j will become 6, it was 4. Then j in prime, yes, it is there, so you're removing 6. Step by 2, 8, remove 10, step by 2, 10. So it is available in the list, so remove it. So actually we are removing all the multiples of 2 starting from 2 till 30. So the process as demonstrated earlier, we are removing the multiples of 2 from the list. So once this iteration stop, this is how your list will be like. So once this you are coming out of it, so you reach here, so I is equal to I plus 1, so I was 2, now I will become 3, right? I will become 3. Now 3 less than or equal to 5, yes, got inside. If 3 in prime, yes, 3 is available. Now j in range, 3 star 2, 6, 6. So 6, is it available in the list? No. So now step by 3, so 6 plus 3, that is 9, that is getting removed. Now 9 step by 3, 12, that is already not there. Again step by 3, 15, that is getting removed. Step by 3, 18, that is already not available. Now reach 21, that is available. So if 21 available in prime, prime dot remove 21, so we are removing 21. Next step by 3, so 24, 24 already not available. Next, 24 plus 3, 27. Yes, it is available. So we are removing 27 plus 3, 30. So we reached n plus 1, right? So we are coming out of it, and your I will become I plus 1. So I will become 4. So again, 4, is it available in the list? So since 4 is already a composite number, you need not repeat the step. So you are coming out of it. Now you increment I by 1. I is equal to 5, right? So 5 in the prime list. Yes, 5 is already available. So j in 5 star 2, that is 10. 10 is not available. Increment by 5, so it will become 15. 15 also not available. Go here, step by 5, so 20. 20 is also not available. Reach here, step by 5, so it is 25. So 25 is there, so 25 is getting removed. Then step by 5, that is 30. 30 getting that is not already removed from the list. So we reached 30. So we are coming out of the loop, and we reach here the statement which is after the for loop. So that is I plus 1, that is I will become 6, right? Okay, so now I less than or equal to math dot square root of n, and this value returned square root of 35.48. The integer part of 5.48 is 5, that is getting returned. So this is exceeding it, so this is turning out to be false. So you're coming out of the while loop. And now once you come out of the while loop, you reach at this statement, that is prime, which is the list which is having only the prime numbers. So if you could observe, what is left with is the prime numbers, right? Okay, so what we can do is that we can execute and see this program for once. So the values which were fed in, I'm just removing it, reinitializing back that to 2, and let us just execute the code and see. Okay, so first let us enter the number 30. So if you could see the prime numbers uh, which are available in the range of 1 to 30 are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. So the list got printed. Maybe we can run one more time. Maybe we will give 50, right? So 50. So the after 30, 31, 37, 41, 43, 47. So we got the correct answer, right? Okay, so so this is one of the most efficient methods for generating prime numbers up to a given number. So the method is called a sieve of Eratosthenes. We could do it very efficiently using the list class in uh, Python. So hope you have enjoyed learning this algorithm. So thank you for watching. Happy learning.